Monday. I'm refreshed. Okay, here we go. 6-2, day 1.
You have your clicker on, right?
I do.
Okay, good job.
Thank you.
You're welcome.
All right. We're going to be solving trig equations today.
Oh, good.
Solve trig equations.
Is that definition?
Nope. These are the directions for theta.
I understand.
And this time I want theta to be between 0 and 360 degrees. So what does that mean about what quadrants I'm going to be looking in? All of them. We're not limiting it to just the 2 inverse ones that we did on Thursday. So, right into examples. This is not going to be a bad day for you.
I know, it's like they all look plotting. Okay, thanks for the clarification.
Okay, our goal here is to solve for the sine of theta. And algebraically, this is not going to be too challenging. Think of that sine of theta as an x. How would you isolate that sine of theta? What do you do first? Subtract 1 from both sides.
Oh, God. So, minus the 1. Please tell me.
So we've got 2 sine of theta
Divide by 2.
equals -1. Now what?
Divide by 2.
Divide both sides by 2.
Good.
So the sine of theta equals -1/2. Now what do I have to do to both sides?
Divide by sine.
Not divide by sine.
The sine negative
Inverse
1.
sine.
Inverse sine on both sides. We're going to do inverse sine on both sides. So you know here on the left you get just theta. Remember with the inverse sine of the sine, you get the little thing inside? Equals the inverse sine of -1/2. So what this is asking for is what angle values have a sine equal to -1/2, but you have to look all the way around the whole circle because of the directions that said all the way around. So that's just your circle sheet now.
Does that sine with the -1 throw any other things off?
Mm-mm. Nope. Where on Thursday, when we didn't have that the restriction of all the way around, we had to just use the first and fourth quadrant. Now we're just going all positive angles, 0 to 360. So you just look on your sheet.
Are you looking for angles?
We're looking for our answer is the angles.
210.
And I want them in degrees because of the way I gave this answer, degrees.
210
210
330.
and 330.
and 330. Everybody okay with finding 210 and 330? Okay, that's solving a trig equation. Are they all going to be that easy?
Yes.
No. So that was the easy one. Each one's going to have a little twist to it now.
Like a box set in there, or how many?
I don't know. I haven't turned the page yet. Okay. 2 cosine squared theta minus cosine theta minus 1. Okay, what kind of equation is this?
That's fine.
It's a quadratic.
That's a quadratic.
Okay. I want you to see it as 2x squared minus
We're going to factor.
x minus 1 equals 0. We're going to factor it. I mean, I know it's not x's, but think of it as x's. It's 2 times something squared minus that same something, something minus 1 equals 0. How would you factor this, 2x squared minus 1? Oh, come on. Yes, you have. So you got a 2x and an x.
Is that the same thing as?
I'm going to do it with x's. We're reverse FOILing. We're going back to what did I FOIL to get that? This is algebra 1
Yeah, see, the
and
problem-
algebra 2.
A lot of us just failed it and then we moved
Oh,
on.
okay.
So,
All right. What you've got to do, you want factors of -1 here. What 2 numbers multiply to -1?
1 and 1.
Positive 1 and -1. Okay, I'm going to show you what to do here. So it's a guess and check thing. If I put, I'm going to make it wrong first. I'm going to put -1 here and a positive 1 here. It's a guess and check thing. What you want to have happen when I do the 2 inside terms and the 2 outside terms, the innies and the outies I call them, When you add those together, you have to get -1. Well, what am I going to get right now? What's negative 1 times x?
Negative x.
Negative x. What's 2 times a positive 1? 2x. When I add these together, what do I get? A positive 1x. That's not what I want. So how can I make this happen for me?
What's that?
Make this a positive. Make this one the negative.
Off of that, wouldn't it be, like, that's not part of following.
Yeah, it is. That's the outside and the inside. I didn't do the first times the first. That's what's going to give me my 2x squared. And the last times the last is going to give me my negative 1. That's outside, that's inside. The outies and the innies give you the middle term.
And then the 2x times the negative 1.
So, now, so factoring was not supposed to be the hard part. Okay.
Never learned it.
Okay. Well, we'll probably have another one in here. So, what I know now is that because I've got two things multiplied together that equals 0, right? Do you see this as thing 1 times thing 2 equals 0?
Yeah.
Do you agree that one of those things would have to equal 0 in order for the product to come out equal to 0?
Yeah.
So either 2x plus 1 equals 0 or x minus 1 equals 0. But I don't want x. What is my x actually equal to?
Theta.
Cosine theta. I replaced cosine of theta with an x. So now I'm going to stick the cosine back in. So I kind of left the cosine to just do it with algebra so you don't get confused. But now I got to put the cosine back in. So 2 cosine of theta plus 1 equals 0, or cosine of theta minus 1 equals 0. And now I solve each one of those, just like example 1. So I'm going to subtract 1 from both sides. Yep. Divide by 2. Cosine of theta equals negative 1/2. Over here I'm going to add 1 to both sides. Cosine of theta equals 1. So we'll do the inverse cosine on both sides and then find those values on the circle sheet. So I've got two things to look for. Where on the circle sheet does cosine equal negative 1/2? Go all the way around. I want angle measures. Where does cosine equal negative 1/2? 240 and 120. I also have values when cosine equals 1. So what else? Where does cosine equal 1? 0 degrees and 360.
Gucci.
Oh, yep.
Does the 0 and 360 come from the positive 1?
Yes. So not only did we have to look for negative 1/2, which were these first two, we also had to look for 1, which were the last two. So all 4 of those are solutions to that quadratic equation. So factoring quadratics might be a little bit of a challenge for you. I might have to help you with that. All right, so it's solve them outright, factor with a quadratic. Here comes another one. The little trick.
So that's just it?
Yep, our goal is to find the thetas.
Sure there isn't a button we can press on our calculator.
Well, you could do inverse cosine of the negative 1/2 and the 1, but it's only going to give you the 1 value. Because remember the 2 quadrants that the inverse function is limited to on the calculator? It only gives you 1 of them. It'll give you the 120 and it'll give you the 0, but it won't give you the other 2. That's why we have to have the circle sheets. Number 3. Can you solve sine of theta times tangent of theta equals sine of theta?
Seems simple.
Seems simple. What would be your first step?
I would divide by sine,
Or split
and
tangent
then sine
apart.
cancels out.
Wow, I did not think of that.
Yeah, I know, that's why I'm here.
I don't know that we'll get all the answers, though.
Tangent would be
Oh,
1,
hey,
so then
but
we get
tangent.
225.
Yeah, because there's 4 answers. You would only get 2 of them. I guess you can't get rid of any trig functions. That's probably a bad thing to do.
Split tangent.
We're going to subtract sine. This is another one of those, boy, which way do I start?
Yeah,
If we
see,
sub-
I would have dug myself into a hole.
Yep. You would have eliminated, by eliminating one of the trig functions, you would have eliminated a couple of answers by doing that.
Oh, okay.
So if I subtract sine on both sides, I'm going to have 0. So don't eliminate trig functions. Now we're going to factor this, but this is not a quadratic, so we don't have to do that binomial business. I want you to see this as 2 baskets. Here's basket 1, and here's basket 2. When you factor, you have to take out what's common to both baskets. What's common to both baskets?
Fine.
We're going to take out a sign from both baskets. What's left in the first basket?
Tangent.
Tangent. Minus what's left in the second basket?
Nothing.
1. Because we're doing like reverse distributive property. You have to have something there, so when I distribute back in, I get back what if I put a 0 there, I wouldn't have that second basket anymore. So, what we've got is thing 1 multiplied by thing 2 equals 0. Do you agree that each of those things, one of those things has to equal 0? So either sine of theta equals 0, or tangent theta minus 1 equals 0. So the first one's ready for the inverse sine on both sides. So, where'd that red pen go that I just had? Here. You don't have to, no. You don't have to write this out. You can just go right to your circle sheet if you're ready. So that tells me that theta equals the inverse sine of 0. Over here, I've got to add 1 first before I can do inverse tan. Now we'll do inverse tan. And now you look for both values on the circle sheet and give me all the thetas. Because we're going all the way around 0 to 360.
Wouldn't that be tangent, the inverse of tangent plus 1?
Nope. Of 1, just do the inverse tan on each side.
Oh, okay.
0 and 360.
Wait,
Yes? Yeah. 0 and 360 are the same spot. I don't even know if the book puts both of these down. They might just put down the 0 and not the 360. I wouldn't mark it wrong if you did, but that's my guess. And 180. And then over here, where does tangent equal 1? 45 and 225. So we had 5 answers there if you include the 360. I don't know. I'm going to look in the book and see, because it all depends on the very first thing I wrote down. But the way I wrote it down, we went, because this is not including 360 because I rounded it. But if they've got a squared, which I have in my notes, so I don't know which one it is without looking in the book to see what they've got. So if it's rounded like this, we would not include 360. If it's bracketed off, we would include the 360. So it all depends on the directions. Kind of my mistake for not really paying attention there. All right. I have 2 left for you today. I'll go with the new sheet. Well, it's a nice day. You'll be done early. These are the tricky ones, though. No longer what we just did. So, we've got tangent of theta plus the square root of 3 equals secant of theta. Oh, I think I threw away that half sheet. Dang it. I'm going to dig that back out. Okay. This one. There's no factoring for us to do because I've got a tangent and a secant. The trick to doing this one is to square both sides. So it's just a trick. So when factoring doesn't work, and you can't just solve because you got two unknowns in here, the trick is to try squaring both sides. So of tangent of theta plus square root of 3 squared equals secant squared. How do I square the left-hand side correctly?
Sold.
You FOIL. You don't just get to distribute that squared in. So it's the tangent of theta plus square root of 3 multiplied by itself. And the right-hand side is just going to carry along as secant squared. Okay, foiling. We're going to get tan.
First,
Gives us
tangent squared.
tangent squared. Outside,
Tangent times square root of 3.
so square root of 3 tangent. Inside,
Same thing.
square root of 3 tangent. Plus
3.
3. Okay, the reason we squared this one, we would like to get it down to one trig function. And we can because of a Pythagorean identity. Who still has their half sheet with those original identities on it?
I do.
What's the identity for tangent squared and secant squared? What can I replace secant squared with?
You?
Probably a 1.
It's like,
Yeah.
no,
Yeah.
it's not equal to 1.
Wait, a tangent and a secant?
I want just secant squared.
Here. Here.
Oh, you got it? Oh, good. Thank you. Right here. Here's the one. Secant squared equals 1 plus tan squared. So in place of the secant squared, I'm going to put 1 plus tan squared. Right here. Watch and see what happens. This is going to be 1 plus tan squared. Okay, why is that nice? What can I do now? I can subtract tan squared from both sides. Well, that's going to be nice. Well, we want to get down to one trig function, which we, nope, I'm done with that. Okay. So what is square root of 3 tan plus square root of 3 tan?
2.
Very good. 2 square root of 3 tan plus 3 equals, what do I have left over here? 1. No, don't minus 1. I want to solve for tan.
Minus 3.
Minus the 3. 2 square root of 3 tan equals negative 2. Now what? Divide by 2 square root of 3. See, I don't think we got rid of the tan squared, but we still had tan in here. I think that's why that's okay, because we didn't really eliminate tangent from the problem. We just eliminated a version of tan. So I got tan theta equals, what am I going to have here?
Negative 2 square root of 3 would just be negative square root of 3.
I'll have negative 1 over square root of 3 when I cancel the 2's out. But am I going to find that on my circle sheet? No, you got to hit it with a 1 to see what it actually we're going to look for. So we're going to have negative square root of 3 over 3. Now you can look for a tangent, a couple of tangent values.
330.
330 and
150.
and 150. Now, the trick, I doubt you remember this from advanced algebra, but when you square an equation, like we did at the very beginning, we squared both sides, we made a brand new equation that helped us solve it out, you can get what are called extraneous solutions, extra solutions. They are solutions to this thing that we squared, but they're not solutions to the original equation.
No.
Do you remember that from advanced algebra?
Yeah.
A little bit maybe?
I remember that word.
Extraneous? Only when you square both sides can that happen. So you need to check for extraneous solutions.
It's gonna be any longer than the other one.
Oh, is it a little longer?
It's a lot.
Oh, it's a lot longer. Okay, so all you need to do now is take both of these, plug them back into the original equation, and see which one or if both work. Most times when you square something, you'll have an extra solution that's only a solution to the squared one but not the original. So I'm going to go back to the very first problem and type in 330 for the tangent, or the left-hand side of the equation. So I'm going to go tan of 330. I don't know what mode I'm in though. I'm in rating, that's not going to work for me. Degree. The tan of 330 plus the square root of 3. Okay? Now I'm going to check the right-hand side. I need the secant of 330. How do I get a secant? 1 divided by cosine of 330? Are they the same?
Yeah.
Yes, so 330 works. We're going to keep this answer. And now I just plug the 150 back in. So it's the tangent of 150 plus the square root of 3. I get that. And then 1 divided by the cosine of 150. Not the same.
Why are you using cosine?
Because I'm trying to find secant. Secant is 1 over cosine.
Oh, okay.
I'm plugging it right in here. 1 over cosine is secant.
Wait, can you do that again and explain it slower?
I'm just typing 150 in here and here. So I did tangent of 150 plus the square root of 3.
Okay.
Got that answer.
Equals secant.
Now I'm checking. Does that come out equal to the secant of 150? Well, secant is 1 over cosine because I don't have a secant button. So I did 1 over cosine of 150 and I get negative 1.15. These two answers are not the same. So 150 was my extraneous. It will, if I plugged it back into my squared one here, it would work, but in the original one it does not. So the only time you check for extraneous is when you squared both sides. Okay, last one. Number 5. Tangent squared,
So which one didn't work?
the 150. Nope, it's not an extraneous one.
Probably words.
What do you want? What do you see this as? What kind of equation is it?
Oh, it's Pythagorean identity.
It's a quadratic equation.
Close.
See this as
I don't know.
x squared plus x minus 2 equals 0. Do you see that as that quadratic equation where my x is tangent?
I have a problem.
What's your problem?
Why is it?
Oh, it shouldn't be.
Okay, that was my problem.
I was thinking I was going to go to x's next, and I just did it a little bit early. Yeah. Okay, factoring a quadratic back to Algebra 1 and Algebra 2. Let's factor first, then we'll substitute the tangent back in afterwards. It's already equal to 0, so I can use my thing 1 times thing 2 property. What's going to go in the first 2 spots here? Because I have to get an x squared, so it has to be just x and x. There's no other option. And then the last times the last has to give me a negative 2. What are my options to get a negative 2? I get a 2 and a 1. One's positive, one's negative. So I know I've got a 2 and a 1. What do I want to end up with when I add my innies and my outies? I want to end up with a positive 1.
So the 2 would be the positive.
That would give me a positive 2x. And that would give me a negative 1x.
Wait,
And
what are you? I don't understand that. How? Can you explain that?
mm-hmm.
I don't understand all that.
Well, first, I'll start from the beginning. This times this has to give you your x squared. So your only options are x times x. And when I multiply this spot times this spot, these two multiplied together have to give me this number.
Oh, yeah, I get that.
So I only have a 2 and a 1. So I didn't worry about the plus and minus yet. I need to get a negative 2. So I know one of them has to be a negative, one of them has to be a positive. Right? I don't know what it is yet, but I know one of them is positive, one of them is negative. That's where the innies plus the outies give you this middle term. So I put my 2 and my 1 down, and I said when I multiply these two together, that's giving me my inside term, and I multiply these two, that's my outside, but when I add these two together, I want to end up with a positive 1. So if this is 2x and this is 1x, I want to end up with a positive 1. So which one has to be negative? Should the negative be here, or should the negative be here?
I that in my head, so I've never heard of that. It just made it complicated.
Oh. Okay. So now we've got thing 1 times thing 2 equals 0. So that means either, I'm going to replace it with the tangent now, are you okay? X is actually the tangent of theta plus 2. Either that equals 0 or tangent of theta minus 1 equals 0. And then we solve both of those and then look on the sheet.
How come you got rid of the square? Like where it said, at the beginning it says tan squared theta?
Mm-hmm.
How come you not use the square?
Because I factored it. If I was to multiply these back together, I get my tan squared back. Okay, so I'll subtract 2. Tan theta equals negative 2. Add 1. Tan theta equals negative 1. Okay, let's get the negative 1 out of the way first. Oh, positive 1. Thank you. This one's not a problem. Where does tangent equal 1 at? 45 and, what did you say? 225. Okay. Tangent equal negative 2 anywhere on that circle sheet?
No.
But it does equal negative 2 somewhere.
Oh, hey, 315 and then 135.
No.
No? Oh.
No. That looks like negative 1 to me, not negative 2. Okay. You have to pick up a calculator here. You have to, it's not on your circle sheet, so you got to do an inverse tan of negative 2. What's the inverse tan of negative 2? Okay, she said, are we agreeing with negative 63.4 degrees? We'll just round it off there. Is that what you said? Okay. Is negative 63.4 between positive 0 and positive 360? That actual number itself? No. I need a value between 0. How do I just convert that to something that's between 0 and 360? Add 360 to it. So we don't want any negative answers. Not that that's wrong. You're just not quite there yet. So if we add 360 to it, what are you going to have? 297.6?
Or, well, it would have been 296.6.
296.6. Okay, we'll go there. All right. Wouldn't you like to be done there?
Yes.
But you're not. Remember the calculator, the inverse trig function only looks in 2 quadrants. Is there another spot where tangent's negative at?
Subtract 180.
So you found this one right here. It gave you this one, that negative 63 degrees. Where else is tangent negative? Which quadrant?
Probably 2.
It is 2.
Yep.
Where this angle here would be that 63 degree angle. 63.4. How do I get the positive angle to get to there?
Subtract 180.
From?
296.
So 180 minus the 63.4?
What?
There's a couple ways to get there.
Okay, redo it.
Oh, you could subtract 180. Oh, I like your subtract 180 from that. Oh, I like that too.
Wait, subtract 180 from what?
Oh, the 296?
Okay, start over.
Okay.
We typed it in.
Okay, we found this angle first, the negative 63.4.
Yes.
And we couldn't leave the negative, so we added 360 to it.
Yeah.
So we found this angle right here was 296.6.
Yeah.
Okay? Then I said, there's also another spot where tangent's -2. It's over here in quadrant 2. But it has the same reference angle. It's got to be on the same line as this one. So they said take 296.6 and just back up 180. That would work just fine. So what's 296.6 minus 180? 160.6. I don't know if I gave you many of these tricky ones. 116.6. Thank you. Okay. That's it. Okay. Don't worry about the really tough ones at this point, because I kept them easy. I think I kept them easy today. Tomorrow we're going to do some more challenging ones. Page 257. No, I think I got everything today. I just don't think I gave you a lot of these difficult ones today. 7 through 25 odd. So you can be checking them in the back to see if you're supposed to be finding more answers and whatnot.